Task number 2, what is a hash function? This task is part of the hashing Crypto 101 module, which is part of the complete beginner path on TryHackMe. Hash functions are quite different from encryption. We touched a bit on this in the last video at the end of it. There is no key. So in a hash, there is no key. In an encryption, there is a key. You saw again yesterday. Go back to the task number 1 and you will see an example. There is no key and it's meant to be impossible or very, very difficult to go from the output back to the input. A hash function takes some input data of any size and creates a summary or digest of that data. The output is a fixed size. It's hard to predict what the output will be for any input and vice versa. Good hashing algorithms will be relatively fast to compute and slow to reverse. Go from output and determine input. Any small changes in the input data, even a single bit, should cause a large change in the output. The output of a hash function is normally raw bytes, which are then encoded. Common encodings for this are base 64 or hexadecimal. Decoding this won't give you anything useful. A hash, firstly, is a hash function will result in raw bytes, which will be then encoded, right? Again, go back to the video of yesterday and you will see examples of hashing and encryption. Why should I care? Hashing is used very often in cybersecurity. When you log into TryHackMe, that used hashing to verify your password. When you logged into your computer, that also used hashing to verify your password. You interact indirectly with hashing more than you would think, mostly in the context of passwords. What's a hash collision? A hash collision is when two different inputs give the same output. Hash functions are designed to avoid these as best as they can, especially being able to engineer or create intentionally a collision. Due to the pigeonhole effect, collisions are not avoidable. The pigeonhole effect is basically there are a set number of different output values for the hash function, but you can give it any size input. As there are more inputs than outputs, some of the input must give the same output. If you have 128 pigeons and 96 pigeonholes, some of the pigeons are going to have to share. MD5 and SHA-1 have been attacked and made technically insecure due to engineering hash collisions. However, no attack has yet given a collision in both algorithms at the same time. So if you use the MD5 hash and the SHA-1 hash to compare, you will see they're different. The MD5 collision example is available from here, and details of the SHA-1 collision are available here. Due to these, you shouldn't trust either algorithm for hashing password or data. So you can read more here. MD5 collision demo, mscs.dal.ca. Over here is the URL and you can read more there, or this one, shattered.io. We have broken SHA-1 in practice. Answer the questions below. What is the output size in bytes of the MD5 hash function? Actually, copy paste. This is the exact same question and paste it in Google. 16 bytes. The hash size for the MD5 algorithm is 1 to 8 bits. The compute hash methods of the MD5 class return the hash as any array of 16 bytes. Note that some MD5 implementations produce a 32-character hexadecimal formatted hash. So 16. Can you avoid hash collisions? No. At some point, it will happen. If you have an 8-bit hash output, how many possible hashes are there? 2 to the power of 8. 256 possible hashes from an 8-bit output.